Hi students, welcome back to Physics for All YouTube channel. In today's session, I am going to explain you about very important topic in entire semiconductors unit, that is Hall effect. So all of you listen carefully about this statement as well as the derivation of Hall voltage. Okay, so in this Hall effect question, first of all, we have to understand about what is the meaning of Hall effect. Okay, so go through the definition properly. When a magnetic field is applied to a current carrying semiconductor, when a magnetic field is applied along the current carrying semiconductor, then in addition to the applied electric field and magnetic field, new potential difference is going to develop in a direction perpendicular to the both electric field and magnetic field. This phenomenon is known as a Hall effect, and in this phenomenon the produced voltage is called as a Hall voltage. Okay. Now this is the statement of the Hall effect. Listen carefully. This statement is important for the short answers in some cases. Okay. Now repeating the statement once again. When a current carrying semiconductor is placed in a magnetic field which is applied perpendicular direction, then due to the applied electric field and magnetic field, new potential difference is going to produce in a direction applied perpendicular to the electric field and magnetic field. This phenomenon is known as Hall effect, and the produced voltage is called as Hall voltage. Now the next step is we have to get derivation of the Hall voltage. Okay. Now to derive equation for the Hall voltage, now we need to consider one semiconductor. For this reason, I am going to consider one semiconductor material. It may be N-type material, maybe P-type, maybe intrinsic, whatever it may be. Now this is a semiconductor. Okay. Now the semiconductor has three dimensions. So this is a X dimension, and it is a Y dimension, and it is a Z dimension. Okay. Now according to the statement of the Hall effect, now to this semiconductor I am going to apply electric field along the X dimension. Now along this semiconductor I am going to apply electric field along the X dimension. So on this semiconductor in this X dimension I am going to apply electric field. So due to apply electric field, I is the current passing through the semiconductor along the X dimension. Okay. Now at this instant you can apply. Now at this instant, all of you listen carefully, it is very important. Now at this instant you can apply magnetic field. Now you can apply magnetic field perpendicular to the X dimension, that is equal to along the Z direction. I am going to apply magnetic field to this semiconductor. So what you can understand, I am applying two electric fields here. Number one is a electric field. This electric field applied along the X dimension. Okay. In addition to the electric field, I am also going to apply magnetic field along which dimension? Along the Z dimension. Okay. So because of applied electric field and magnetic field, new voltage is going to produce. In a direction perpendicular to the both Z dimension and X dimension, that is along the Y dimension. So this is a positive charge is going to induce along the upper side of the semiconductor, and negative charge is going to produce on the lower side of the semiconductor. Therefore this induction of positive charge and negative charge in a direction perpendicular to both electric field and magnetic field, that is along the Y direction. This phenomenon is known as Hall effect. Here the produced voltage is called as Hall voltage. This is about the statement of the Hall effect. Okay. Now we will go for the derivation part. Okay. Now due to the Hall voltage, there we will observe the Hall potential difference that can be written in the form of Fe is equal to E into Eh. This is the applied electric force due to the Hall voltage. So Fe is equal to small e into Eh. In that expression, small e is the charge of the electron or charge of the charge carrier, and EH is the produced Hall voltage. Okay. Now we will come to the magnetic field. Now the magnetic field applied, which can be represented by using Fm. What is the meaning of Fm? Fm is a applied magnetic field along the z dimension. That can be written as Fm is equal to BeV. In this equation, what is the meaning of B? B is a applied magnetic field. B is applied magnetic field, and E is a charge of electron. E is a charge of electrons, and V is the velocity. V is the velocity of the electron. Okay. Now at the steady state, we can equate first equation and the second equation. What is the first equation? Hall electric force Fe, and equation number 2 indicates that magnetic force. So equation 1 is equal to equation 2. Now what is equation number 1? E into EH is equal to B into EV. Now in this expression we can cancel small e and small is going to be a cancel. After cancelling the small is, what is the remaining term? EH is equal to BV. EH is equal to B into V, where EH is a Hall electric field, B is a applied magnetic flux density, V is the velocity of the charge carrier or velocity of the electron. Now let us consider it is a equation number 3. Write down the equations, important. Wherever you are not understand, you give me the message. I will explain you once again in the form of other video. So EH is equal to B into V. Then coming to the, already we know that from the lower classes, we know the relation between the voltage and the electric field, that can be written in the form of EH is equal to VH by D. Now in this equation number 4, substitute the third equation. The third equation is equal to EH is equal to BV. Substitute EH is equal to BV in this expression. What is this? Is a EH is equal to BV. Already left hand side is equal to VH by D. Equate these two equations. What you can get? Right equation for the velocity. So I need equation velocity. Velocity V is equal to VH divided by B into D. In this equation, let us consider, this is the equation number 5. V is equal to VH divided by B into D. In this expression, VH is called as the produced Hall voltage, and B is the magnetic field applied, and D is the thickness of the semiconductor. Okay. Now already we know general equation for the current density J is equal to NEV. Now in this J is equal to NEV, let us consider it is equation number 6. Okay. Now in this equation number 6, we know already from the previous topic, J is equal to current density, N is equal to number of charge carrier, E is a charge of the charge carrier, V is a velocity. Now in this equation number 6, substitute velocity. Velocity, what is velocity? VH is equal to V is equal to VH by BD. Substitute in the above expression number 6. What we can get? J is equal to NEVH by B into D. We can consider it as equation number 7. Already we know that another equation for the current density J is equal to I divided by A. What is the meaning of J? Current density, and that is equal to I by A. I means what? Current, and A is the area. So what is the difference between the current and current density? Current density is a vector quantity. Current density is a vector quantity, whereas current is a scalar quantity. That is the difference between the current density and current. Okay. Now let us consider it is equation number 8. Now what we have to do? Equate 7th equation is equal to 8th equation. What is the 7th equation? NEVH by, this is the 7th equation, NEVH divided by B into D. Now in that 7th equation, equal to 8th equation. So NEVH is NEVH divided by B into D, that is equal to I by A. What is the meaning of I by A? I is the current, A is the area. We know that area is equal to, already we know that from the lower classes, area is equal to length into breadth. So in this expression, that length is you can take in the form of d, breadth is equal in the form of w. Therefore, I am considering NeVH by b into d, that is equal to I divided by d into w. In this equation, observe left hand side and right hand side. Where are the similar terms you can cancel? What are the similar terms? Small d is a similar term. Okay, cancel. After cancelling, what is the remaining part? Remaining part is equal to NeVH by b is equal to I divided by w. Now we modify this equation. I need equation for the Hall voltage. VH is equal to IB divided by, so what you can get, NEW. This is a expression for the Hall voltage. Now we can consider it is a ninth equation. So VH is equal to BI, that is here also, both are same. Okay, so VH is equal to BI by NEW. In that expression, B is the magnetic flux density applied, I is the current passing through the semiconductor, N is the number of charge carriers, and E is the charge of the charge carrier, and W is the width of the semiconductor. Okay. Now in the above expression, in the place of 1 divided by NE, I am using one constant, that is called as a Hall coefficient. Okay. Now wherever 1 by NE is there in the above equation, you can treat that as a Hall coefficient represented by RH. So that above equation means ninth equation can be written as BI divided by, in the place of 1 by NE, what I am writing? RH. So BI RH divided by W. This is a equation for the Hall voltage. VH is equal to BI RH by W. That is equation number 10. In this equation number 10, what is the meaning of B? B is equal to magnetic flux density. B is a magnetic flux density. This is applied along the which direction, my dear students? Applied along the Z direction. Then what about I? I is a current. What is the meaning of I? I is a current passing. I is a current passing through the semiconductor. I is a current passing through the semiconductor along which dimension? X dimension. Then what about RH? RH is a Hall coefficient. What is the meaning of RH? RH is equal to 1 divided by NE. This is a constant. This constant is known as Hall coefficient. And finally W. What is the meaning of W, my dear students? W is a width of the semiconductor. This is about the Hall voltage expression. Now writing this Hall voltage expression, we need expression for the conductivity. Conductivity is equal to sigma is equal to Ne mu. So how we got this equation? This equation already we derived in the previous concept, that is conductivity of a semiconductor. Also we discussed it in the drift current in the semiconductor. In order to get about this definition, you can go back my channel and refer the previous videos. You can get equation for the conductivity, that is sigma is equal to Ne mu. In that expression, mu is the mobility of charge carrier. Then write equation for the mobility. Mobility is equal to mu is equal to sigma by Ne. Already we know from the previous discussion 1 by Ne is equal to RH. So in the place of 1 by Ne, what I am going to apply? I am going to use RH, where RH is a Hall coefficient. So mu is equal to what I can write here? Mobility of the semiconductor. So our carrier is equal, mu is equal to sigma into RH. It is a equation number 11. Now what we need? We need equation for the resistivity. What is the resistivity? Reciprocal of the conductivity is called as resistivity. So rho is equal to 1 by sigma. What is sigma? From the above expression, nu mu. So 1 by nu mu. So resistivity is equal to 1 by sigma, that is equal to 1 by nu mu. 1 by nu means RH. So what you can write here? We can write resistivity. Now we can write this equation. What you can write? So right hand side rho and right hand side, left hand side is 1 by Ne into mu. What is the meaning of 1 by Ne? We can write the form of RH. So RH divided by mu. So finally what you can write? Rho is equal to RH divided by mu. This is a relation between the resistivity and Hall coefficient. This is about the another expression, that is a 12th expression. These are the expressions required in the case of the Hall effect. This is very important topic. Definitely it will come to the examinations. So all of you practice well all the equations, we can get a correct idea. Okay, if any doubts, comment me, then I will get some more clarity. Okay, now we can discuss about the another one is applications of the Hall effect. So using this Hall effect experiment, we can have some applications. What are those applications we can discuss in detail? So very first application is Hall effect experiment is used to know the given semiconductor is intrinsic semiconductor or extrinsic semiconductor. This is the first point. Okay. Now the second point is Hall effect experiment is used to know the given semiconductor is n-type semiconductor or p-type semiconductor. How can you find n-type or p-type? Simply by identifying the Hall coefficient value. Already we know that Hall coefficient RH is equal to 1 by Ne. RH is equal to 1 by Ne. If you will get Hall coefficient is positive, if you will get Hall coefficient is a positive value, then the given semiconductor is p-type semiconductor. Similarly, if Hall coefficient is negative value will get, then the same semiconductor is known as n-type semiconductor. Therefore, Hall effect experiment is used to find the given semiconductor is n-type semiconductor or p-type semiconductor. This is another application. Okay, and one more application is Hall effect is used to calculate number of free electrons and number of holes in the given semiconductor. That is the third application. And fourth application is by knowing the Hall coefficient and mobility conductivity of semiconductor, we can calculate the mobility. How can you calculate mobility? Use the expression number 11. What is the expression number 11? Conductivity sigma is equal to what you can write here? Mu divided by RH. This is from the equation number 11 we are getting. So sigma is equal to mu by RH. So using this expression, we can calculate mobility of the charge carriers can be calculated. That is about the fourth application. And the fifth application is if electric field is known, then magnetic field can be measured. These are the different applications of the Hall effect. This topic is very important for the university examination. So all of you go through these equations and practice well. This question can be asked in the examination, either essay, either they may ask in the essay question, or it may be asked in the 2-mark question. In the case of 2 mark, they will ask, they will give about the statement of Hall effect, or they may also ask about what are the applications of Hall effect. It may be important. So this statement as well as the Hall effect, these two are the important for the short answer question, whereas the entire topic is important for the essay. But overall it is very important question. This is about the applications of Hall effect, derivation of Hall effect, complete information. Okay, if you like this channel, please subscribe my video and share to your friends. Okay, thank you very much for watching this presentation. In the upcoming video, I will explain you the remaining topics. Okay, please watch carefully. Okay, thank you very much.